Section 8.4, choosing sample size. We have two goals. Compute the sample size to be used for estimating a mean, mu, and to compute the sample size to be used for estimating a proportion p when we have an estimate for p and when we do not have an estimate for p. In previous sections, we've found the intervals in where we think the mean is going to fall, and a byproduct of that is we also have to be able to estimate the sample size needed to get to a given level of confidence. This is all based on the amount of error that we want to allow. And so if we take our error equation, being the critical value times standard deviation divided by the square root of n, and solve for n, we get the equation to find the appropriate sample size. To find the appropriate sample size, we'll take our critical value times the standard deviation divided by the error and then square all of that. So this whole thing is squared. That will allow us to find an adequate sample size to be a given level of confidence that a mean is going to fall within a given interval. So this is finding an n that will work for us. To do an example, a wildlife study is designed to find the mean weight of salmon caught by an Alaskan fishing company. As a preliminary study, a random sample of 50 freshly caught salmon is weighed. The sample standard deviation of the weights of these 50 fish is S is equal to 2.15 pounds. How large a sample should be taken to be 99% confident that the sample mean, x bar, is within 0.2 pounds of the true mean weight mu. So when we're looking at this, we already have a sample of 50 fish. We're looking at how big of a sample, including those 50 fish, do we need to have 99% confidence that we're within 0.2 pounds of their true mean weight. So we have standard deviation of 2.15 pounds, 99% confidence, and our error in this case is 0.2 pounds. That's how close we want to be at 99% confidence. So standard deviation 2.15, E 0.2, and then the critical value is assigned to the given level of confidence. We looked at this in sections 8.1 and 8.2. I'm going to bring in a little chart here which you'll all have to use, but here are the critical value or the confidence levels and the critical values associated with those. We would let you use this on some type of assessment because we're not asking you to memorize, but I'm going to pick the critical value that is associated with 99%, and that's 2.58. So my critical value being 2.58, I will plug this all into the formula. So I have 2.58 times 2.15 divided by 0.2, and we're going to square that whole thing. When I do that, I get 769.2, and so that we include that 0.2 because that's how big our sample has to be, we're going to round up to the next whole number. So 769.2 will round to 770 fish. Now, just so you know, we did look at a sample of 50 fish already, and if we need 770 fish total, so we would have to go out and catch 720 more fish in order to meet the appropriate sample size for this scenario, because we did already catch 50 fish prior to figuring out the correct sample size for this study. Moving on, estimating sample size for proportions. This goes back to 7.3 stuff. It says, just as we can estimate sample size for population, we can estimate sample size for proportion. If we have a preliminary estimate for p, we use this formula here. And if we do not have a preliminary estimate for p, we'll use this formula here. The difference being that when we have the study, we have probability of success. So we can plug in P and Q. This is Q. When we don't have the preliminary study, we need to come up with a general number, or that's what they've come up with, and that's a fourth. And so if we don't have success, or the probability of success, we'll use a fourth, and if we do, we'll plug P and Q into this formula here. Z, C, and E are the same thing. ZC is the critical value, E is still the amount of error. And so if we do an example, we have a company that is in business of selling wholesale popcorn to grocery stores. The company buys directly from farmers. A buyer for the company is examining a large amount of corn from a certain farmer. Before the purchase is made, the buyer wants to estimate P, the probability that a kernel will pop. We are doing a 95% confidence interval and an error of 0.01. If no preliminary study is made to estimate P, how large a sample should the buyer use? So in this case, we have no study, meaning we have no P. So our formula will be a fourth times the critical value divided by the error, and if I bring that chart back in, 95% is 1.96. So we'll do 1.96 divided by 0.01 squared. When I do that, I get 1.96 divided by 0.01 squared times 0.25. So there we get 9,604 kernels. Again, not having done any preliminary study, not knowing the success that they have on their kernels. If we do have the preliminary study, it shows that the probability of success is 0.86. If the buyer uses the results of the preliminary study, how large a sample should be used? And so in this case, since we do have P, we will use the formula here to find sample size. And it'll be 0.86 times 0.14, again times 1.96 over 0.01 squared. So notice there, the 1.96 over 0.01 squared did not change. The only difference is the having P and Q. When we do this one, we again take 1.96 divided by 0.01 squared times 0.86 and 0.14. And in this case, we get 4,625.28, and again, round up to include that 0.28 of a kernel, and we get 4,626 kernels. This is a wrap-up of Section 8.4, choosing sample size with both raw data and proportional data. The assignment down here on 417 and 420 will be adjusted in class.